So far, so good. We haven't exploded anything or smoked anything out yet, but it's early. We got 3.5 minutes left with Jesse Miller, our resident chemist, teaching lab specialist and REACT program director at the U of I. And last time we did some reactions with acid, the sulfuric acid, and
that's right.
We moved on to different ones.
Yeah, we have a couple more strong acids. We got nitric acid and hydrochloric acid. And like I said, each strong acid tends to have different properties. They're all similar in that they're acids, but some things are used for some things, and some things are used for others.
Okay.
One of the things I was going to show you about the hydrochloric acid, when you dissolve a metal in an acid, and this is magnesium, and this is a 3 molar hydrochloric acid. Hydrochloric acid is the same acid you have in your stomach.
Okay.
To digest food. And this is a little bit stronger than that. Well, when I add the magnesium to it, it's going to dissolve in here, and you're going to see a lot of steam because it gets very hot. And it evolves hydrogen gas because it's an oxidation reduction reaction that's going on in here. So I'm going to capture that gas here in this balloon. All right, so here we get going. I'll put this on here.
Okay.
Oh. Didn't go that way in rehearsal.
Never does, right?
All right, there we go. So we're revolving hydrogen gas, and yeah, it's pretty
nasty.
Pungent. Well, you know, chemistry is pretty smelly, most of it. Most of this we do under the hood, so you don't ever notice it. So I have to be kind of careful as to what I actually.
Yeah, this is safe for us to breathe, right?
Oh yeah, this is just hydrogen gas. Well, as long as we don't light a match, we'll be okay.
This stuff's trying to say, well, you know, it could make you sick later. You may have to leave work early. It won't do that, will it?
No, I don't think so. There's a little bit of steam coming out there, and I just wanted to show you this is indeed hydrogen gas. If I can actually get this with his gloves on. There we go. And
voila.
There we go. So there's some hydrogen gas given off by that.
Very cool.
So that's kind of neat. But it turns out that some metals are harder to dissolve than others. Gold and platinum, they had a hard time ever figuring out how to dissolve that. It was discovered that if you mixed hydrochloric acid and nitric acid, you created something called aqua regia, which dissolved gold and platinum. But I didn't make any aqua regia, but I do have a copper penny here, which hydrochloric acid won't dissolve. Sulfuric acid dissolves so-so. But nitric, turns out it works a little bit different than the other two in that it's the nitric part of nitric acid is a very strong oxidizer, much stronger than, here it is, than the hydrochloric or the sulfuric. So whereas they won't dissolve it, this will, and I'm only going to put a little bit on there. You can see it starting to turn green, and you'll see a brown gas in here. Okay, and that brown gas is nitrogen dioxide, or N2O4 or NO2. It's in equilibrium. This is actually what comprises smog. Okay, this is what's coming out of the back of your car that we're all worried about.
So this is good for us to breathe?
Well, no, it's not good for us at all. But I only made a little bit, so we won't have to worry about that too much.
Okay.
Now, nitric acid's importance in the industry, as among other things, is making explosives. Okay?
Oh, okay, well.
Okay, so what I have here is just some regular cotton that I put in nitric and sulfuric, okay, overnight, and then dried it out. And what happens is the sulfuric acid dries out some of the water, and the nitric acid nitrates the the cotton. I'm going to move this.
Let's all
so this is what we call gun cotton. This is actually nitrocellulose. They use this now for propelling bullets and things, and also in fireworks. And it's very touchy. There we go.
Wow, that's gone in an instant.
Yeah, and there's nothing left. It's pretty. It's pretty cool. I got more if you want to do it again.
Well, we have 30 seconds left.
All right.
We'll let Ann come in because I know she wanted to come in here and play with us some of this
stuff.
You
want to come in and light this off, Ann?
I don't think she's around.
Well, I'll let you do it.
All right, I'll do it. You hold this.
Okay.
Okay. Well, ready, Don? Wow. Very cool. That's very interesting. Now, there is a use for that. We're not just kind of playing around.
No, like I said, it's nitrocellulose. They actually use this for in place of gunpowder. They call it smokeless gunpowder.
Okay.
You know, that's the reason why back in the old days when they were using black powder, you'd see the big puffs of smoke and things like that. And nowadays, when they shoot guns, there's really not that much smoke coming out because you're using nitrocellulose.
There you go. Jesse Miller, thank you very much. We appreciate your time. You want to see a replay of these segments, just go to our website, IllinoisHomepage.net. Look on the morning show. Look under Chemist Corner. We'll be back right after this.